when we discuss intermolecular forces, we have to be careful and get it straight in our heads, the difference between intramolecular forces versus intermolecular forces. Okay, it's very important to get that clear. The intramolecular forces are the forces that hold atoms together, inside the molecule. We call those bonds, in particular covalent bonds. Intermolecular forces are the forces holding discrete molecules or ions together. Okay, so those are the forces holding discrete molecules or ions together in a condensed phase as a solid or a liquid. That's what condensed phase means. Okay, and so we have to be really careful when we look at an ionic compound versus a covalent compound to keep the difference between, are we talking about intra or inter? Now, as it turns out, we call the attractive force between ions in an ionic compound, we call those ionic bonds. But what we're going to come to realize, since the sodium and the chloride ions are discrete, you know, and if you melt this, or if you dissolve this in something, or if you put it into a gas phase, you're going to end up with discrete sodium ions and chloride anions anytime you separate the crystalline structure. And so that's actually what we would consider an very, very strong intermolecular force. But it's so strong, it's you know, when we introduce this concept to people, we introduce it as a bond, and it bonds, you know, as we'll see, are electrostatic attractions. So this is really a very, very strong type of intermolecular force. We use it loosely because we know that these aren't molecules, that's inter between the discrete ions. This might look kind of complicated, but this is, the red is oxygen and the white is hydrogen, and what you see here is ice. And so in this picture we have intermolecular forces and intramolecular forces holding the individuals together. So let me see, here's an individual water molecule, and that would be an intramolecular force, and this would be an intermolecular force. So intra versus inter.